Hello everyone. So we will be talking about chaos and behind the scenes of Kubernetes production. So you must have, like, if you're working in the Kubernetes, you know, like, how big is the cases in the production, yeah. So my co-speaker will share a lot of cases around the company she works for and similar kind of use cases. So yeah, so about me, so I work at Tycoon as a principal product evangelist. I'm also CNCF ambassador, GD, and Docker captain. So if you want to connect me or ask any doubts, you can reach out always. And I will hand over to Vinuja to continue. Yeah.
Hi, I'm just DevOps engineer at TuneAI, and I basically mostly work on Terraform, Kubernetes, CI/CDs, and all of that. So I have a lot of stories to share, but we'll share the top ones over here today. So basically, it starts from deploying LLMs. What is the ideal infrastructure that needs to be there to make the deployment of LLM successful? So first of all, we need powerful computing resources, which could mean GPUs, highly available CPUs, TPUs, and more. And then we have networking infrastructure to, oh wait, how to do back? Okay. Networking infrastructure, it basically means that it should be available for the high bandwidth and low latency to use the LLMs. Memory and storage is needed to save the massive data which has been used for fine-tuning and training. How LLMs should be accessible, and they should be easy to integrate in the existing systems, and able to serve the applications they are integrated into with the API endpoints and what not. Next, we have containerization. So if we are just deploying one LLM, it's fine. But we are planning to deploy more LLMs, then we need more containers, and with that, we need orchestration for that. And if we are giving our data to the LLMs, we need it to be secured, right? And it should not have unauthorized access to it, and our data should be properly secured. And after deploying all of this into the infrastructure, we need it to be monitored to basically help us to monitor its performance, and then to analyze its behavior, its accuracy, and then we should manage it by providing regular updates, bug fixes, and improvements. So this is the ideal situation where our LLM will work successfully and properly as expected. But there are some challenges to it, which basically means to that, so whenever we are deploying LLMs, the infrastructure needs to be scalable. And when we are scaling, it's very difficult to manage the auto-scaling dynamically, because the demands grow, and we do not know how to scale at that point. And then when it comes to the resources, there is very huge question that what resources should we use? What do we use? A100s or do we use H100s? How many GPUs do we use? And how many memory CPUs do we allocate to the deployments? The next is reliability, which basically means how much is the uptime of the LLMs that we are using. Is it completely available all the time? And how does it work when the network goes down? How does it work? What is its behavior when there is issue in infrastructure? And if you have used tried to deploy LLMs, you might have known the startup time it takes to actually start the LLM and the deployment. So and it also comes to the point where it makes it more difficult when using auto scaling. So when we try to scale the system when there's a issue, the next deployment is replica is already taking a lot of time to start. So there are a lot of complexities over there. And once the model is deployed and we want to integrate into our systems, so there might be re-engineering over there to integrate the models into the existing systems, and then or creating new systems, or using just these API endpoints. And the deploying powerful LLMs needs powerful infrastructure, powerful security, so it also implies powerful cost as well. So to help with all of the challenges, we have some developer platforms. These developer platforms help us to simplify the deployment process, which basically we do not have to use only CLI. They provide good dashboards and UIs, which is comparatively simpler to just use some drop-down options and then just deploy your model, and then you have your endpoint with you to use it in your application. And which is faster as well. The scalable infrastructure point comes here, which the platforms are configured in a way that it can handle all of those things, and it also supports the GPUs and TPUs as well, and it can help you to make a choice of what GPU should be used for which models, and it makes it easy to handle large volumes and traffic and data as well. And for storage and networking, most of the platforms are integrated with the object storage, and they let you store your data over there, and it's easily connected to the deployments. The serving endpoint is the main thing that we are deploying our LLMs for. It's basically to get the LLMs used in our applications and make it customizable according to our needs. And most of these platforms are secured in a way that they have some ISO certifications, SOC certifications. So we can rely on those platforms to put our data on that and use those infrastructures. So this is the very basic architecture of how these platforms would be deployed onto the production. The platforms that helps us deploy the LLMs, not the LLMs itself. So if you can see flow, it's very simple. The user is using from the UI, the web interface, and it's basically put on the load balancer or the API gateways, whichever is comfortable according to the engineers. And the backend has a lot of parts for it. The compute engines mainly is used for the compute that is going to be used to deploy the LLMs. The data storage, as I said, the object storage or the complete data that is being used for the deployment of LLMs, and the infra engine, the complete engine that is going to be make that deployments available to the user. And a lot of other servers, I have just written 1, 2, 3, but those servers could mean authentication server, billing server, payment server, and a lot of other servers as well. And the whole thing is always connected to the database. And I have just shown one database over here, but in the real architectures, there could be multiple databases over there. You could use SQL, PostgreSQL for different reasons, and all of this architecture would be having monitoring set up on it, and would be having CI/CDs and all of those things. So and we've seen that it actually requires a lot of infrastructure and a lot of efforts to put this into the production. And mostly you will see this on the screen when you are trying to deploy Kubernetes. After all of this crash loop backups, I would like to share the top 3 Kubernetes blunders that happened with me when I was trying to use Kubernetes in production and try to deploy these platforms. Sorry. The first one actually is about the I'll give the context as there are, consider there are 2 deployments in one Kubernetes cluster, and there are 2 different namespaces as well, and there are 2 deployments in the 2 different namespaces. So the deployments are of the same server, and those server has 2, that deployment has 2 different pods. So the pod 1 and pod 2 in the namespace 1 and the pod 1 and pod 2 in the namespace 2 are of the same server. And these deployments are being used for different and multiple reasons on the production. So this is one of the manual tweaks that we made into the production, and we kept it as it is unless and until we needed it to be changed. So one day, my colleague and I decided to make this change and to make this deployment in a single, to make 2 different deployments into a single deployment so that can be used for everything and not the 2 different things. So, yeah. So we decided to remove one deployment and keep only just one deployment. We are making these changes while getting on a huddle into the Friday evening, and then we just have one deployment, and we just deploy it, create the Docker image, push the Docker image, and then deploy it. For some reasons, I decided to do it manually. And then I see on the dashboard that this deployment is running. And there's a green mark, the deployment is running. We tested everything once, and then we got all the good results. And then we were like, OK, fine. Next thing we see is the pod 1 was only deployed, and the pod 2 was not updated with the manual image. And all of this happening was simultaneously a marketing campaign was happening for the company. And from the users, we are getting to know that it is not working for them. But when we did test it, it worked for us. So we just cannot tell them that it works on my machine. But yeah, so when we went to check the logs and all of those things, so we can see that in the same replica, in the same deployment, pod 1 has been updated with the latest image, but not the pod 2, and which led to the finding that what could have been the problem. So the problem was the insufficient memory on that particular node. So how did we fix it? So we manually updated the pod that was outdated, and we had to restart the whole deployment. And then when we were making changes, we also had to make some DNS-based changes. It was basically based on the URLs and external URLs, actually. So just insufficient memory can cause your production down. So basically, the precautions could be taken as if allocate the sufficient memory to the resources when you are deploying huge resources on your nodes. Then you have to consider the amount of memory it might require, and we should not overcommit the memory as well. And then, sorry, we can keep the auto-scaling enabled but what if I know that I will need only 3 nodes, and I am keeping the auto scaling's maximum value as 3, but what I believe is we should keep it at 4, so it might help in cases like this. Setting up alerts for the memory usage, and yeah, do not make changes in production directly, or just test thoroughly when you're making it, and also do check the marketing schedule before making the changes. The next is, yeah, so there is this production, and I am tasked with deleting the clone of the production that has been created by using Terraform. And so what I'm doing is I took the Terraform code which has already been used for the creating that clone, and I am trying to destroy all of this with step by step, and then I'm doing Terraform plan to check what all resources are getting deleted, and then run the Terraform destroy command. So when I run the destroy command, I can see the error, and it is not able to delete some resources. So I went to the dashboard, checked from there what is happening over there, because Terraform does not really provide a lot of logs that where it is stuck. So I found out there's this one resource. It was Clickhouse, and it was installed with the help of Helm, and it was in a namespace called Clickhouse as well. And the Clickhouse utility object had a finalizer spec in it, and because of that finalizer, Terraform could not delete the resource. And so what I did is I went there and I edited that resource manually to remove the finalizer so that Terraform can delete the resource, and so all the other resources can be deleted altogether with the Terraform. And and then I ran the Terraform distro again, and it did try to delete the Clickhouse, the deployment, and the namespace as well. So I can see now the Terraform run Terraform destroy has completed, and the resource has been deleted. The next thing I see is I started getting alerts from the production setup on my Slack. My Slack started getting receiving alerts. So was just wondering what just happened, and only to know that the Clickhouse resource, which was on production, that was deleted. So how could have that has happened? Then I just checked that kubectl context was set to the production cluster, and because I had used kubectl delete to delete the Clickhouse resources, and it was deleted on the production itself. Then. Yeah, so basically we had backup strategies set for the Clickhouse on the production. I could recover it at that time, but yeah, the precautions I could have taken was checking the very first thing is to checking the context before using the kubectl, and I mostly use kubectx tool, which actually helps in retaining and changing the context. But as I was using kubectx, I did not have the habit to write the context argument in the command line every time. So I just did not use it, and Yeah, I mean, before deleting, verify twice what kubectl context you have set on your command line, and then proceed with the kubectl delete, and yeah, have backup ready for almost everything. And also, if you have backup ready, try to recover from the backup once, so just that you know that backup does work. Um, and here is the greatest one, which is which so previous one was to delete the clone of the production. This one is to create a clone of the production, and so it starts, so we have to create a clone of the production. So what I did is, I fetched the Terraform code from the production branch, and I created a new branch for that and started making changes on that branch. And so we just have to make a clone, right? We'll change few values over here and there. We'll change few variable names. We'll change some location variables. And then I did Terraform init, and I could see the plan that these things are going to be created, and those are going to be created in a new cluster. New cluster is going to be created, and then with the new name, all of that. So I applied that plan, and I can see the cluster is created. I can see the so basically how it goes is, we create cluster first, and then we create deployments, then we create services, then we create ingress to publicly expose those deployments via service and the other required resources. Then this Terraform state is getting updated step by step by the time we are doing Terraform init, Terraform apply, and that. So it's been almost 4 or 5 days. I've created a setup or clone of the production. It's working fine. And then one of my colleague wanted to make some changes to the Terraform. So he tried doing something, and he was getting errors. Why? Because he could not get the Terraform state on his computer because it was corrupted. And we also had backups, and the backups were also corrupted. But because we had already been using for 4 or 5 days, right? So they were all gone. And then we get to know that the Terraform state file for production was overwritten. And how it was overwritten? So we had to when I was using the Terraform, I did not change the remote backend configuration, and it was set to the production as well. So it got overwritten, and we had to manually import all of those files one by one. Those were around like 200, 220 resources, which we got into huddle for like 3-4 hours and imported it manually. Yeah, so basically there is a state logging thing for, So there's a state logging thing for Terraform. We did use it, but it did not work for some reasons. And I should have listened to this warning that my computer gave me that Terraform might damage. Yeah, so yes, so these are some precautions that should have been taken to manage the Terraform state files. And I think I'm running out of time, so I'll let Rohit continue from here.
Yeah, she was so excited. I wanted to cover it in 15 minutes, but I left it 5 minutes, so we'll just run out.
Sorry.
Yeah, so some of the best practices we can do to avoid this kind of production issues. It's like we can't avoid it, but yeah, we will try. So Gitops, yeah. If you know about Argo CD and Flux and these tools, right? So Gitops is nothing but a practice, which is it is an operational framework that takes your DevOps best practices for like deployment, management, and monitoring. So what actually is a Gitops? I will just run it off. Like Git is your universal truth here. So it is a single source of truth. Everything will be considered to the Git, and then you just have to run through the. There are two options, Argo and Flux. So Argo is actually the developer experience centric, and Flux, as a founder from other companies, suggest like it is operator centric. So how actually the flow will look like? I have the example. So if you see here, developer pushes the code, it commits the changes in the Git repository, which will have the application code, and then CI pipeline will just trigger, and it will run some build and test, and then create one Docker image. And that Docker image can be pushed to the Docker registry. But on the other hand, it is always best to keep the two Git repositories, one for the code and one for the K8s manifest and your configuration codes and stuff. So updates will be done on the K8s manifest repo. And similarly, Argo will be sitting there. It will also monitor the changes in the K8s manifest, and also it will pull the changes. So Argo is the one who will sync at every time. It is like it runs on the pool-based model. So whatever happens in the Git, it will adjust it according to desired state and production state. So there is operations team which will configure as well as manage this Argo, K8s manifest and Argo. And it also works for the multiple case cluster, so it, like you can run it to provide like more security, resilience, and stuff. So yeah, if manual changes are detected, it will just detect it and revert it. If it is configured to do so, it will not automatically do it. So that's what is written here. So what is coming next? Logging and monitoring, right? So shout out to Mimnits. He makes amazing, he or she makes amazing memes. So logging and monitoring. So just consider this diagram now. We'll go fast. So let's say there is a LLM application and they are in the pods, right? So whenever they generates like logs and metrics, right? You can just push it to the promptel to collect the logs, and then Loki is there to query the logs. Prometheus is also runs on the pull-down kind of a model, so it will also use that matrix. Matrix is nothing but your numerical information, and logs is your information about the events which is happening in the application pods. So this scrap matrix and queries, logs will all combine into Grafana, and then visualization will occur. And similarly, you can create the multiple dashboards. I don't have time, but yeah. So this kind of architecture it looks. Similarly, let's see. So this is kind of architecture many companies uses. I will not say which, but yeah, many companies use it. So if you want to check like how the production level things work, so then canary releases always like it is one of the practices. Like if you know the blue-green deployments, right? It is similar to that one. So you just release something for the beta users, and depending on the practices and whatever test you run, you can release it for the future purpose in the main version. So like releasing to small subset, and then it helps in the A/B testing, beta testing, and risk mitigation, and also you can check for the parallel change pattern, which helps a lot. Then yeah, there are really amazing tools are developing in the CNCF as an open source project. K8GPT is one of the favorite. So if you are excited about AI and you want to use it in Kubernetes, shout out to Alex and other folks on the CNCF. They are doing amazing work. So K8GPT is something I will say quickly. It's like if you have something running in your system, like if you want to monitor your Kubernetes cluster, you can simply use it K8GPT inside that, and it will explain you the logs and whatever important anomalies is going on. And actually, it anonymizes the data of yours, and it sends to the GPT or like any AI models, and then you can AI model just gives you the answer. Similarly, there is one of the another project is going on, which is KubeAI. It is like a replacement for like OpenAI, but for the private GPT for the Kubernetes. So it is really exciting project. You can learn about it more. I will also share the slides. So it just takes the ML things, and it is like a reference to the OpenAI libraries, so compatible with it. So you can use the similarly you use the OpenAI. So yeah, this is how the K8GPT looks like. So if you want to check, it is also available on the website. It just you will see like once analyze or filter is run, it will give you the logs in the plain English and this language. So yeah. So I have been I have been through the Istio service mesh a lot, but yeah. So if you know like how what kind of a model API gateway we can run through the AI, if you are deploying the AIs and all, like what kind of API gateway you can run. So nothing but you can see like if you have the Kubernetes workloads and stuff there, so you can't simply route traffic directly to the LLMs, right? So you can use the security team to define the security policies, then gateway team to use the technical information, routing spec and all, and then pass it to API gateway. Then it will route it, combine everything, and pass it to the AI models and all. So really a lot of information, yeah. So this is another thing, backup and disaster recovery. So if you know about the Velero tool, it's really simple to use, open source project. It's nothing but it creates a custom resources for the AI models and then fetch it to Kubernetes API, backup controller gets it, queries it, and it uploads to the cloud provider, and then snapshot. It creates the snapshot. So it is simple to use, and it you can use the backup of any cluster and restore it to any new cluster without any worries. So yeah. So promise me. So this is just a company I work for, advanced management Kubernetes service, what you can actually build. So it is like a Kubernetes platform. Any Kubernetes platform, it is not about just a cloud work. You can build which has like anything inside it, like self-service, then application as a service. So you can pick your application. Then there is a catalog. You can use the Helm and all, build it to your Kubernetes platform. So everything in one side. We need this kind of a Kubernetes platform, and it is really helpful. So yeah, thank you. If you have any doubts or any questions, you can always reach out to my handles, or you can ask me. Sorry for being late. Yeah.